Structural discontinuities. Porosity. Gases are produced or released at high temperatures and when unable to escape, remain in the solid metal. Inclusions. Most common inclusions that appear in the welds are slag, metal, oxides, and non-metallic solids that are entrapped during the welding. You can have a picture. Porosities. Scattered, clustered, and linear. These are linear. Upside is scattered. Second one is clustered. Incomplete fusion and inadequate joint preparation. Incomplete fusion can occur at any location where the base metal or previous pass weld metal has not been brought up to fusion temperature. Inadequate joint penetration, when present, usually occurs in the root area of the weld and is caused by similar reasons, namely sufficient heat up for fusion doesn't reach the bottom of the groove or mismatch. Undercut. Undercuts are the result of melting base metal and not replacing it with weld metal, leaving a notch or groove. It is due to high temperature and high speed. So there are like fusion zone, scattered slag, bond line slag, root area slag, type and location of slag location. So incomplete fusion, B groove fillet weld. You see both. So incomplete fusion, B groove fillet, incomplete penetration. Penetration is not there. Undercuts. So there is a notch. Cracks. The cracking of weld metal and base metal in or near to weld zone is usually caused by high stress set up by localized dimensional changes. So high stress is there, temperature is below, brittle material, so it will start cracking. So if the temperature is above some range, it may, or PWST, so the cracks may or may not occur. But high stress is the problem. Longitudinal and transverse cracks, crater cracks. Crater cracks are small shrink cracks that can occur in the weld puddle at the end of a weld bit that is not been fully filled. So at the end, you have to fill it. For GTAW mainly it is coming. For others it is very less. Cracks in the hedge of base metal occurs mostly entire. It is heat treated hardenable, means preheat not there, post heating not there. So as per your WPS problem or something, it may happen, or you don't follow your WPS. These are longitudinal and transverse cracks. These are crater cracks. Surface irregularities. Occasionally, surface irregularities and imperfections may be nuclei of future failure. So that's why it is important. Residual stress and heat affected area. So complex thermal stresses occur in the parts during welding because it is the same as a casting process, one layer after the other. But though in casting process you are putting all layers one time, here you are putting one layer, then again normalizing it, then again cooling it, again normalizing it. So recrystallization and so everything is going on. During the welding, the weldment undergoes shrinkage and deformation. As it is a casting, open casting, so it undergoes shrinkage and deformation. So there is transient thermal stresses, residual stresses, distortion, and sometimes cause cracking and mismatching of joints. Distortions and stresses. Bond line crack extending into base metal. Root and toe cracks in the base metal with fillet welds. For ductile materials, this may not happen. For hard materials, if preheat is not there, preheat is not maintained properly, these cracks will be there. Restrain Restraints create stresses and distortion. Restraint means you object the localized shrinkage or distortion. With restraints either on the heating or cooling or with heating or cooling of localized areas, a more rapid rate than others. All welds create residual stresses. Stresses and distortion are associated. See, there is, if you are welding with a single bead, you put some restrainer here or tack weld here so that it will not become like a bow. So all these things, this also is welding from one side, that's why it bends to one side. There's the distortion, lateral distortion also there. The stress is reduced by preheating, pinning, so intermittent pinning, post heating, preheating, everything will help to reduce the post heating. Longitudinal distortion is weld but pipe weld. Longitudinal stress in the butt weld. Grain uniformly requires transform. Normalizing provides stress relief and addition increase the uniformity of grain structure. Stress relieving of weldment is frequently performed by heating to about 650 degrees centigrade for carbon steel. Where while grain refinement is not obtained at this temperature, the chances of distortion are less than those might be introduced by the allotropic transformation, which occurs at higher temperature. Effect on grain size and structure. Cooling rates higher than casting because it is very thin layer. So grain formation in fusion welds can best be understood by remembering that fusion weld is a casting. So same here, the fusion limit. Mold material conducts heat from the casting. Unfused base metal conducts heat from the weld. So if it is heat sink means it is taking out the heat quickly. Then it is problem. So preheat is the best. So it cannot sink heat because heat is already there. So heat will remain here. So it will not affect too much. It will not give too much stress and all. Comparison of casting with the fusion weld. So weld metal liquid solidification by the formation of columnar grains and straight shrinkage at the weld surface. Heat affects the base metal. There is a zone which is called heat affected zone. So it is affected by this heat. Its tensile property will affect, bending property will affect. This is the grain structure. After welding. So limit of visible heat affected zone, the larger grains, and sudden cooling. So you have small grains. So slowly it will become the larger grains and all. Multiple cooling rates. Preheat lowers the cooling rate. Effects in pressure welding reduced. Localized heat most common. Destructive testing of welded joints. So what are the destructive testings we are doing? Mainly tensile, bending, and notch. The longitudinal transverse tension test, several bend tests, and drop it or notch test. So these things are there. Weld metal and base metal. Weld metal and base metal properties. The base metal is superior always, and the weld metal, because of hardness and different impurities and different alloys or any problems, so it will be the less it has less tensile strength or bending stress than bending strength than this base metal. The hatch zone is the most affected one, so it has the less tensile and all properties. Uh, Typical base material discontinuities: non-fused joint in welded steel pipe, lamination in a rolled plate, cracks or tears in casting, inclusion of scale in a steel forging. So this chapter finished.